Yeah, trying to reconnect. The moons have moved again. Now you can't see there's a third moon there. Way off to the lower. And I don't know, there's some kind of artifact happening in this telescope. I was really hoping to get the cloud bands. Zoom out a little bit. I zoomed in a lot there. Zoomed in enough to get those moons. And there's a moon way off about 5 o'clock. Way off in the distance, like, I don't know, maybe 5 widths of the planet. There it is. I zoomed in and got it to pop in just for a second. It'll probably disappear though when the planet goes back into view. Oh, there it is. Welcome to Jupiter. It's not quite dark. I was really hoping it would focus because you can see the cloud bands. It's twilighty. I can't get any shape out of Venus except for round. So, come on. And that third moon does not want to cooperate. That's Jupiter tonight. At twilight, and then about 3 o'clock, that's something in this telescope I haven't figured out. It wasn't originally there. I kind of thought it might have been light pollution from the getting in behind the shroud on the front of it, but I made sure that was good and seated, and it's not coming from that. But I can tell anyway. Come on, where's that moon at? I get it just off the side of the view, and it was popping in because I think the cat. There we go. You can almost see it. I can see it on his phone. It just does not want to show us the cloud bands. It's like a diagonal equal sign there. Maybe I put this on a big computer screen, it'll show it. But there's the moons moving yet again. Two on one side and one on the other. Where's the fourth Galilean moon? Well, I can't tell if it's in front. It could be in front of Jupiter. There's the third moon. Twinkling a little bit. But it disappeared. The camera contrast or, aperture. Camera aperture closes down when it gets in front of the camera and it vanishes. So there's a fourth moon there somewhere. Oops. I just barely moved the telescope and I just saw Saturn go flying by out of the top end of it. I've got to be very, very close and very careful to keep that in view. There's that moon. And it'll vanish when Venus comes into view there. To the naked eye, though, all you can see is three of the moons. Where's the fourth Galilean moon? It's either behind the planet or in front of the planet. And if it would straighten up, hey, all right, it's just gotten a little bit darker, and now we can see that third moon. Where's the fourth moon? I don't know. I wish I could figure out what that. Ooh, I can see the cloud bands there for a second. It's like a diagonal equal sign between the 2 equals 1. Should equal 2 equals 2. Where's the fourth moon? Where's it? It's got the slightest little bit darker, and the camera is now showing that moon. Well, it was. There it is, barely glinting in. Come on. Man. I can remember which way to turn the slow motion controls. Come on, where's that at? There it is. See it? That's tonight's dim, faraway moon of Jupiter. Here comes Jupiter. I suspect maybe within 45 minutes or so, the fourth moon might all of a sudden show up. From where, you might say? Well, with the rinky-dink yard sale astronomy, you can't tell if that moon is in front of Jupiter and it's just washed out in the brightness of the planet. But I'd say it's behind it. And I'll check back in a little while and see if we see it. Showing up. But man, that other moon is fickle, ain't it? We get Jupiter out of the camera view, it shows it back up. Well, sometimes it does. There it is. And that's hard to do. You wouldn't believe how hard that is to do. Barely touching this thing. You can see every time I breathe on it, just about it shakes. I need to calculate the magnification on this. 20 millimeter eyepiece, and I'm probably zoomed in about 3 times on this digital phone. It does not tell me what the zoom is. It won't tell me when I'm on Facebook Live. It won't say how much zoom I'm doing. Uh-oh. Anyway, that's about all there is to see right now on Jupiter. How about let's go over here to the moon. One of these days, Alice. And then there's no filter on tonight. One of these days, Alice, Norton's going to take you down in the sewer with him. Okay, it's the Honeymooners. Anybody that doesn't get the reference, Jackie Gleason. I would try to get the, 10 millimeter lens, and show you some of these lunar swirls, the Rainier Gamma, swirl I might be able to show. But there's where they want to do a moon base on the South Pole. The contrived space race with the Chinese to get something done. Now, I never did figure out what people were seeing when they say they see the man and the moon. But I've seen it depicted like the crescent moon with a nose and one of these big dark Maria as its eye when it's a crescent. I guess you could say that's two eyes and a nose, sort of. And I got to looking at a profile of Aunt B a few years ago, and I mean a moon. I made a cartoon about clown in the moon. I gave the clown like an Aunt B hairdo outline and a red nose. You can almost see that there. That's not it, but that almost looks like a clown with a ball on his head, and I just totally knocked the thing completely off kilter. Fun stuff there. I tried to move where I was sitting and kicked the tripod leg. I don't know where the 2001 black obelisk is at. They won't tell us. But that's just no filter tonight on an 80mm by 700 telescope, 20mm lens, and maybe, I don't know, let's zoom out. That is no zoom. That's with zero zoom. So here is, I think that's maximum zoom, which on this camera is 4 times. There's neat things where it every lunar day there's a static line that occurs right at the shadow line. There's some kind of static charge that occurs from solar radiation versus the temperature there from light to dark, and between that and some cosmic rays there's these weird swirly patterns that the theory was, until I guess Apollo 15 confirmed it, that the moon has a very, I don't know, bumpy magnetic field, and that there, who knows, there could be some comet impacts that have submerged into the crust, and so there's magnetic, well, they say anomalies. There's magnetic features where it looks like something is making little wind-swept eddies in the dust. And so they were like, we need to look at this, maybe this is a magnetic thing. And so Apollo 15, I think it was, released some kind of orbiting sensor experiment, maybe 100 miles above the moon. And it confirmed that some of these are weird anomalies in the magnetic field of the moon. And so, after further looking at it, sure enough, they deflect gamma rays and solar radiation as well as cosmic radiation. So, and there's a readily available amount of dust there that's affected by this. So, chances are it's magnetic, and there'd be enough there collected up to bury your moon base in a protective layer, on top of the fact that it's going to be giving you some amount of shielding. Some amount of shielding that will occur just because of the magnetic kind of a bottle that exists around these places like Rainier Gamma. And Rainier Gamma is pretty big. So whatever's in that dust, crystals of comet dust, water, maybe some metallic magnetic metals. I doubt if there's a lot of aluminum there, but maybe. There's already, I forget if it was somebody, Chinese maybe, I don't know who it was, India, one of these foreign countries, sampled the lunar regolith and found some elements, crystallized elements that could be harvested. So obviously anything you can make for yourself on the moon with your within your moon base, or in the area surrounding your moon base, that is less expensive because it doesn't have to be rocket launched up there. A Rainier Gamma is on the extreme left of the moon in the northern hemisphere. If you're, if the moon's straight overhead, right now we're looking at, it's in the dark side, a shaded side, I like rather to say. It's on the shaded side of the moon. So when the moon gets to the other half of this, and by the way, I'm using a prism, a recting prism, a mirror, 90-degree mirror. And so it won't stay in place. So for some reason my friction settings don't like where I changed the balance on this telescope, I think. It's not wanting to stay in place when I put it there. Tighten down some knobs and stuff or something. Okay, that knob's tight. Where's the other one? I'm missing one here. Okay, that knob's tight. A filter would help probably tonight, but for some reason on the South Pole there's some craters like you see there where the shadow would rotate within the crater all month long, the lunar month. And some, I guess, planners at NASA think that would be a better option. And, here at Morehead State University, they launched a low energy trajectory probe, which I think they nicknamed the Ice Cube satellite. The Cube satellites were an idea, I guess, to share the escape velocity of the ring around Artemis. It was like a ring between the stages, and they mounted something like, 12 different cube satellites to go into Earth orbit. But if you had enough oomph. I think they used an ion rocket to go in a very low energy trajectory to the moon, and they were trying to look for water ice, hence the name Ice Cube, very small cube satellite. Very low trajectory, or very low energy trajectory to the moon. So I saw them like demonstrate what it would represent, how it would represent or be diagrammed, and it looks like, who did the math for that, to figure that could actually work. I don't know, but it's not rocket science. No, it is rocket science. But so I don't know why they seem to be so obsessed with the south pole of the moon. And I never did find out if the Ice Cube satellite confirmed that there is more water on the south pole. But there we go, looking a little better. The swirls like Rainier Gamma, I think, should be more fully investigated. And NASA has been cut to the point where they're kind of hobbled in the science department, needless to say. But their budget probably compares to the Mercury and Gemini program when you adjust for inflation. Before Kennedy was assassinated, as you may know, that was when he said, before this decade is out, we should put a man on the moon. And then he got killed in Dallas, as we're told. So that lit a fire, I guess, under Congress, and politically they were like, well, we need to honor his goal, and so they were able to do it. A lot of people, I think, don't understand that this Artemis rocket and Orion capsule and the system there that they're trying to build, it's a whole different ball game. So they have to be tested out, and to go to the South Pole is a little bit more complicated, as you can imagine if you've been paying attention. They've tried to send a couple of probes down there, and they have to come down from a screaming fast orbit because they end up in a highly elliptical orbit over the polar orbit, north to south, and the north side of the orbit is really high, so when it comes down at the South Pole, it's screaming fast. I don't know how fast, probably, who knows, 9,000 miles an hour, as opposed to an equatorial orbit would be about 3,500. Apollo and the surveyors and other robot missions to the moon that were more up here, like right there, I think is the Sea of Tranquility, or there's the Tick of Chaos. Sea of Tranquility is the second Maria, right on the center left of your screen. That's where Apollo landed. The Sea of Chaos was looked at for a landing area. They surveyed it with they looked at photography wise, and for some reason didn't go to the Sea of Chaos. Sea of Chaos looks very smooth. Unless you have a really, really good telescope, then you can see, there's craters in the Sea of Chaos. Most probably amateur astronomers only see 2 to 4 craters there. It kind of looks like it has 2 big eyes. But if you're orbiting around the middle of the moon there, it's a much easier orbit. You can orbit at a consistent altitude, 100, 120 miles, and maintain it if you do it right. It doesn't require a lot of maintenance to sit there and correct the perigee and apogee. But whatever craft is going down or coming back up has a much easier time of catching a ride because it's going around the moon like, I don't know, every 80 minutes or something. It orbits faster, obviously, than it would the Earth because the moon's like one-fourth the size, but 1/6 the mass. So the orbit is slower at 100 miles than it is at 100 miles above the Earth. You're going to run into atmospheric drag, but 100 miles, if you want to stay above the atmosphere, you got to go something like 17,500 miles an hour. Whereas the moon, you don't have to orbit that fast. 3,500 will do it. So a lot less fuel to go up and come back down. And just like with Apollo, every time you go down, you can leave pieces behind that could be part of the base, which probably, if they're going to really do this, I suspect there's going to be a lot of robotics involved. And I wouldn't be surprised if it ends up happening somewhere around one of these lunar swirls, like Rainier Gamma. I have ran my control all the way to the end of the worm gear again. I'm going to have to do this. Go the other way. I might as well go over to Jupiter. So I got to go this way and loosen the screw and go backwards. Now, should be able to come right back to the moon, I hope. Getting close. It's so bright. You get close, you can see how bright it is there without even getting it in the lens. So, one of the things, if you spend enough time looking at the moon, you'll notice not all the craters are exactly round. And some of them you get multiple impacts in nearly the same spot, and it'll make it more oval or look oval. But you can tell the moon is curved because look at how the round craters are oval near the end of the crescent, or the half. In this case, we're right about half moon, half of the phase or whatever. But when you get, there's one of those that's got a kind of a double impact. You can see it's got the earlier impact, the crater rim has been eclipsed by the later impact. Anyway, I think one of the Apollo missions, they noticed that they could see, I mean, if you're flying, 80 to 120 miles above the surface, and you go around from light to dark, dark to light, one of the astronauts made note that he thought he was seeing the dust being lifted up on the edge between night and day. Now, Apollo, all of the moon missions, I think, were near to the full moon when they landed. It was almost a full moon, so for Artemis, they weren't concerned about the full moon because they were going to go around the moon, so I think they actually wanted to be able to have more of the far side to be illuminated, so they could see a little more of it. And I don't know, maybe they looked at Rainier Gamma, because it would have been a little more lit than we could see it from here on the Earth. But there's you can see those bright streaks, and I don't know all of my moon geography to know. But on that Maria right there, those bright streaks that are probably from an impact over there in the darker area, or the lighter area. And the dust sprays out. On some of these, you can tell which crater it's radiating from. But that dust that gets thrown up by these impacts collects in weird patterns called swirls. And oh, you can see it there pretty good. The streaks going across the dark areas, that's sprays of dust. And some of those may be from the Tycho crater, which is down here on the bottom. Tycho maybe, I think, is in the dark right now. It's over on the dark side. But you can see that impact. It's got sprays coming out of it. Well, normally that would be in a fairly straight line. There wouldn't be any weird wind-blown look to that. So when you find these swirls, and there's several of them, some of them do look like the geography of the mountains or the crater rims are affecting how that dust swirls around. But man, when you look at Rainier Gamma, it looks like a tadpole with a really long tail that's all, almost like a river of dust coming off of it. And so, astronomers scratching their head goes, I bet you that's somehow magnetic. And sure enough, when they ran a probe around the moon, they found a lot more of those, I think. And there's a bunch of them on the far side, commonly called the dark side, but it's the far side. And to me, it looks obvious that the moon expanded. It used to be a lot smaller, and it's been beat up by the impacts and magma. Those Maria or seas are thought to be when there was more of a magnetic molten core to the moon, and the moon was captured perhaps by the Earth's gravity. There's still people that are clinging on to that capture theory, and the Earth's gravity caused the near side to expand. In the Earth, there's an expanding Earth theory too that goes a little beyond plate tectonics on the time scale. And the mystery's been solved about the racetrack rocks. Racetrack rocks in Death Valley. People got tired of wondering about it, I guess, and they put a GPS tag on some of the bigger rocks and a motion detecting camera, and they discovered, lo and behold, when it rains out there, and the supercooled rain that can occur at night puts a little thin layer of ice on the top of the water where those racetrack rocks are sitting. And I don't know about you, but I've been in our woods on a mountain bike when it's like right after a rain, or you go on a mountain bike ride and it's been raining. That mud is slicker than snot. We'll say it's pretty dang slippery, and so the dry crack lake bed, or the racetrack rock sit, is probably pretty slick. But then the wind whips through that little holler where those racetrack rocks sit, or valley, whatever you want to call it, and it blows the ice up against those rocks, and it's powerful enough that it moves those rocks. A lot of them move in unison, and then the wind will die down and shift direction, and they curve. And it was a real mystery as to what was going on there. Well, compare that to the continents. Earth's continents setting on top of a semi-liquid mantle. And there's been some observations that when you have a lot of cosmic rays, it kind of stirs up things like volcanism, and they think it has a champagne effect in silica-rich magma chambers. So, you know, one story goes, there was a time before the moon, and of course there's, who knows what the Smithsonian has hidden away, but there's cultures that claim there was a time before the moon was here. So something happened, maybe a magneto star, a rogue magneto star from the Sagittarius galaxy, if you think we're from the Milky Way, but some people think we're from the Sagittarius mini galaxy and we're just passing through. So a magneto star, red-brown dwarf, highly magnetic star emitting a bunch of cosmic rays, flies by the Earth, drops off the moon, among other things, causes a bunch of impacts, but causes rapid expansion of the globe and shifts of the continents. And it looks like that's happened at least twice in the Pacific. You know, you got India that was down by Madagascar, gets thrown north and crashes into the Himalayas like it was a frickin' boogie board on the beach. If you've noticed that, just look at the ocean floor and all the dotted lines of mountains and islands off of the tip of India, going all the way south to Madagascar. And, you know, Sri Lanka, Ceylon, looks like it's been pulled away. The same thing with Tasmania, pulled away from the southern tip of Australia. And it almost looks like somebody stuck a big finger in the ocean down there between Antarctica and South America, and just dragged their finger across and swept the water out of the Pacific into the Atlantic, you know. Or something, playing in the mud, you know, looked like a big finger dragging across there. But you look at the seafloor that were shown in the Pacific, and it looks like there's been a couple, maybe three major expansions, and you can see like echoes in the shapes. One of the kind of what I've heard described as a lost continent, way to the east of where is it? They herd all them sheep, and billionaires have compounds on there, prone to earthquakes too. Way off to the east of Australia, I forget the name of that island nation. All of a sudden, and they sound like they're from Australia, but boy, you say something about them being from Australia, it's worse than a Bavarian saying I'm Bavarian, not German. New Zealand, yeah, New Zealand, east of New Zealand, there's a undersea, what I've heard described as a lost continent. There's the Sea of Chaos. A lost continent that the edge of it looks like it was like Brazil was knocked off the top of it. You know, like it's kind of an echo of the coastline of Brazil about where the Amazon comes out. And you're like, what could have done that? the Ice Age or something, split. I did recently read an article in the last 3 years, that geologists think that South America is the oldest continent. In other words, in a biblical, poetic sense, it would have been the land that divided the waters from the waters. And when you look at the way the earth expanded, you can just kind of go, oh, well, look at that. As Africa separated off, and the deserts are the same way. You've got all those dry climates where they have the Nazca lines, and diagonally across Sahara, across into the, what is that Chinese desert? Is it the Gobi Desert? Look at the diagonal line of arid climates that goes from China's desert there, bordering with Russia, all the way back to the Andean mountains. It's like a diagonal line of expansion. I think you see the Saudi Arabian Peninsula has broke away from Africa, where we have all that trouble now with the Red Sea and the Straits of Hormuz, Arabian Sea, or whatever it is. Those all look like they broke apart. Is it the island of Crete? It looks like the Mediterranean expanded too, like the Boot Hill of Italy used to fold up and fit down in next to Africa, and some of the islands look like they've been pulled away from Europe into the Mediterranean. Same thing with all those islands up the north of Canada and Greenland. It's like, gee, the shorelines match up too good. It looks like they fit together. And if you was to reduce the ocean level, like the sea level, down maybe 1,000 feet, then you see all those continental shelves look like they fit together. So, just how rapidly could the moon expand like this? Because there's a lot more of these dark splotches or seas or maria on the earth-facing side, and it's locked to where we see the same side all the time. The things that make you go, And then, of course, it covers the sun up during an average total eclipse. There's some total eclipses that go a little bit beyond total. In other words, the moon is a lot larger. It's like a super moon eclipse, so to speak. Whenever an eclipse occurs, the moon is always farthest in its orbit away from the Earth for that orbit, but not the farthest that it always can be, because that's what happens when you have an annular or a ring eclipse. The moon is farther from the Earth than it usually is. It's exceptionally far. And there's crazy cycles with the moon. It ain't a normal, everybody thinks the moon is 28 days. No, for it to complete a path around the Earth, in our orbit around the sun, it's actually closer to 29 days. But if you plot it, it's closer to like 27.78 or something days, 27 3/4 days. It's not exact. So all these long period cycles with the moon, and almost enough to make you think that the old almanac about when to plant your tomatoes or whatever, like there might be something to that, but because there's between our 365 day and a quarter, 365 and a fourth, or almost a fourth, whatever it is, 365 and 0.2347912, whatever it is, it's not quite a quarter of a day that's left over. So every 100 years, the calendar adds an extra day. I think in 1900 they added an extra day, so February had 30 days. And then the moon doesn't exactly have 13 cycles in a year either. Some people are like, we don't need 12 months, we need 13 months. Well, either way, you're going to have resets where you have makeup days to keep your seasons from progressing. And one way we know that is that the flooding on the Nile, before it got dammed up, unregulated flooding on the Nile always occurred when Orion reappeared in Egypt after summer. It was called the dog days of summer. And Sirius, the dog star, is like a companion to Orion, the hunter, whatever. Not to honor any Egyptian gods, but the hunter comes back and he's got his dog behind him known as Sirius. Well, you go back, 2,500 years ago or something, and the dog days of summer was several weeks off from where it is now. And that's because our equinoxes, the day in which the sun is straight overhead, if you're in the tropics or around the equator, it's called the equinox. The days are pretty much almost exactly equal. Almost exactly 12 hours at night, but not quite. A little more than 12 hours of day on the equinox. So, where those equinoxes are in our orbit around the sun progresses. It changes over long periods. And so that's reflected in when the Nile flooding used to be predictable. Of course, since probably the late 50s, early 60s, there was increasingly flood control stuff that happened in Ethiopia, and the Blue Nile, I think as it's called. Those started increasingly throwing off when the Nile floods. And the Egyptians depended on that to make their soil more fertile. So they always watched, when you see Orion coming up, we're going to have some floods. We need to look at harvesting what we can harvest before it gets flooded or whatever. I don't know. But anyway, they did fairly good record keeping. So we know when the progression, or when the dog star showed up. The dog days of summer is different than it was 2,500 years ago, and even farther back. So it's kind of amusing. A bunch of people found out that their astrological sign wasn't what they thought it was. It's off by a couple of 3 weeks. And NASA, of course, is trying to do damage control because they're saying, look, there's nothing to astrology, okay? You guys are being silly. But yeah, you're not a Scorpio anymore, so raspberry to you. You can't blame your behavior on being a Scorpio, just to give one example. I was going to try to go back to Saturn here, just to see where those moons might have moved to. And I can't see it in the sight scope. Where'd you go, Saturn? Jupiter. Saturn's in the morning sky, and probably can't be seen very easily. I'm getting a dang street light bouncing off of my telescope and throwing me off here. Okay, where's the crosshairs? Can't see the crosshairs? Oh, there they are. Here we go. Maybe. right, Jupiter. Where are you going? I lined those crosshairs up as precisely as I could. Oh, by the way, a big sunspot cluster I did not catch. I wanted to try to catch that, and it went below the trees before I could get it. So, maybe tomorrow, if it's not moved too far to catch. I was trying to zoom out on this. You try to help me find Jupiter here. Come on, Jupiter. Yeah. Huh. Am I looking at Jupiter? There's some pretty bright stars out here. I'm hoping I'm not off on a... No, I think that's it. It showed up, it's on crosshairs. Well. Huh. I zoomed out too, trying to... Well, I had a good piece of luck earlier and got it right in there. It ought to show up. I even zoomed out, I think, to try to make it easier to get it in line there. And usually that's what I can do. If you were watching earlier, I had pretty good luck with it early on. Oh, wow. I can't get it to go to... Big satellite just went over. Bright satellite. That's one of the things I was hoping to catch just by luck, was catch a satellite going in front of Jupiter. Or going past, in the same area. Oh, well, why can't I get that? Maybe I bumped the dang scope. Or the sight tube. Yeah, it should be there. Should be right about there. I can't look in the sight scope and look at the phone at the same time. And my connection is being mean to me, so. Huh. Well, maybe my sight scope got moved. I have a trick here. You can take your eyepiece out and look into the... Okay, maybe I didn't zoom out enough. But you can actually look into the... Well, it's there. It's in the mirror. It's just... There we go. Huh. Crazy. I had zoomed in all the way. I thought I'd zoomed out all the way. All right, now cooperate here. Okay. Come on. Let's see what we're doing now. Let's see if we can get what happened. Where you at, moons? I just thought I'd check before I signed off here and see if that other moon showed up. By chance. Nope. I'm hungry. I gotta get some late dinner. What time is it? Oh man. Anyway. Isn't that funny how they vanish and then come back? I thought for sure I'd have that fourth Galilean moon might peek around the side. I ain't got the patience to wait for it. It may be a little while. I was actually kind of hoping you could see the cloud bands. Crazy how they fade in and out like that. Well, anyway, if you just tuned in, we're looking at Jupiter here tonight. I'm trying to play with the focus knob, gradually moving it. I'm not watching the sky. I thought maybe for a minute there were some jet trails or clouds that moved in the way. 3 of the moons can be seen tonight, but if I take Jupiter off to there, earlier you could see that third moon. There, that's trying to glint in. It just barely glinted in. There it is. So, where's the fourth Galilean moon? It's behind there. I bet later on when it pops in, it'll be bright enough to see it. As it, I think, it's going to come around from behind, but now, obviously I don't have a good enough telescope to see the shadow if it's in front of Jupiter. Can't, whatever reason, I can't see the clouds either. But anyway, fun stuff, right? Yard sale astronomy with inferior equipment. That's kind of what you can do if you're willing to put up with it. And have some outside time with the mosquitoes. I like early spring astronomy a lot of times, or late fall when the mosquitoes give up after a couple of frosts. Plus, the sky can be more clear when it's drier in the dry seasons. Oh well. See if that moon will pop in real quick. Yep, there it is. So, I really was hoping I could get luck be with me and I could catch that moon making its appearance, and I'd be like, where's that moon come from? All of a sudden there's 4 moons. Makes you wonder if maybe the Chinese or some other cultures had telescopes almost as good as Galileo did, and they're like scratching their head going, what's going on with these rings around Saturn and these moons or bright spots around Jupiter? They move from one night to the next.